Okay, so it's great to see a full house this late in the conference. I was convinced it would be empty, so I'm really happy. My name is Marcus Hurt, and I'm working with the Java Platform Group at Oracle. And my job is to look at ways of improving the production time profiling capabilities of the platform, and working with other teams within Oracle to make good use of them. And I'm also the team lead for Java Mission Control. And this session is going to be about a relatively new feature in the JDK, which is called Java Flight Recorder. So this is the agenda. I thought I'd start with a brief overview of the flight recorder and then move on to, this is going to be pretty pragmatic. I'm going to talk about how you can actually use flight recorder, how to start recordings, how to dump them, how to, when you might want to do in different ways to get at the recordings. So I'm going to be talking about how you can produce them, how you can analyze them, important key point to think about when you analyze flight recordings, some common pitfalls and misunderstandings regarding the data that you get from the flight recorder. And if we get time, and I don't think we will, I'll talk about some customization features, so how you can actually record your own data into the flight recorder and how you can adapt mission control, the user interface, very easily to visualize the data in the flight recorder, which is really cool. And since I work at Oracle, I have this mandatory slide which basically says that anything I say is, might change at any given time, and this is just for informational purposes, blah, blah, blah. So, straight to the point. What is flight recorder? It's a high-performance event recorder built into the JVM. And since it is built into the JVM, it's pretty easy for us to capture data that is already being gathered. The JVM is an adaptively optimizing runtime. It collects a lot of information about the environment it's in, about the state before, after GC. There's a lot of information already being captured, and that data we can just record for free. So that data is already available there. We can just put it in the flight recorder. It's a highly efficient implementation. We do things like we go to great lengths for performance. I'm going to be talking a little bit more about that later, but we do crazy things when it comes to time stamping of events, for instance, using system count time, using nanos, for instance, system is too slow, so we have our own assembly for that. We produce binary recordings. It's binary data. You will need to parse them. The very first version of flight recorder actually produced XML. It was pretty verbose. So these are binary recordings, and they consist of chunks. And every single chunk within a recording is self-describing and self-contained. So all constants that were emitted, for instance, you will be able to resolve them with the information that is in the chunk. You will not need to go back in time, to the beginning of time where you might have emitted a constant to resolve what's in your constant pool. So you will have them self-describing. So whatever you need, metadata, you need to be able to understand what is in the recording, such as what a certain field in a certain event type means is also in the chunk. So all you need to be able to make sense of the data is a single chunk. So you can think of it as like an MPEG stream or something. You have almost keyframe-ish behavior, which is also important. So a brief history of flight recorder. It really started out as a project from to get information about how the JRockit JVM was being used in production systems out at big customer deployments. We wanted to know how the JVM could be improved to meet the needs of the customers. And it was just a lucky side effect that customers realized that, hey, we can actually solve our own problems with this. And we decided, since we were a little small Swedish company, we decided monetizing things might be a good idea. So that's what happened. Then in JRockit we had a soft real-time garbage collector called the deterministic GC. And then it started to become interesting for us to understand what was stalling threads except for garbage collections. It was important to be able to show that, hey, we are meeting our service level agreements with this garbage collector. It's something else. It might be bad synchronization. It might be something else. So the SE organization was really happy about that. And I think it was a customer who suggested that, okay, since you can do this with almost no overhead, why don't you just leave it on and let us decide when we want the data? We're not interested in having the data all the time or storing it in immense repositories. We know when something goes wrong because of blah, 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 something else. And why can't we just dump the data when we need it? And that's how the flight recorder was born. And after the Sun acquisition, it was decided that we were to merge the HotSpot JVMs and the JRockit JVMs. So that's what we've done. So this is one of the JRockit features that entered the HotSpot codebase. And it's been around for a while, but in a sneaky kind of way, because it entered the codebase in 7U4 already. So we have had the recorder engine built into the 7U4, but there was no interesting events being recorded at all. So it wasn't that useful. It was useful for WebLogic Server because they used the JRockit APIs to record events relevant for WebLogic Server into this recording engine. So they were happy about having it in 7U4, but we never released the Mission Control client because everybody would have gone, okay, so I did a recording and there is nothing there. So we decided to wait until 7U40, which was when we entered, we reached event parity with JRockit. So that was the old nice JRockit logo sort of thing. There are different kinds of recording you can do. You can have a continuous recording, and those have no end time. You just start them and decide when something happens because you notice it in some other means or way. You decide to dump the data. You must explicitly dump the data on your own. There are also time-fixed recordings, and we sometimes call those profiling recordings, and those have a fixed time. And if you initiate them from within Mission Control, they will automatically be downloaded into the client and shown to you. So they are very easy to and intuitive to handle. And I'm going to use the word recording a lot, and I'm going to mean one of two things, unfortunately. So I either mean the actual ongoing recording server-side that you have initiated and that is running on the server, or the actual binary chunk of data that you've gotten as a result, so the physical sort of recording. And you'll know from context. And if you don't know from context, or I just confuse you, just raise a hand and ask me which one I mean. The server-side kind of recording, it's easier to think of it not as a cassette tape, but rather a named collection of event type settings. So a setting for what you want to record. And I will explain why in a little bit, because we do some ugly things in the name of performance. So here we go. Why this is confusing. We share buffers behind the scenes. So if you have two ongoing recordings, we're not sort of going to doubly record events and then separate them into the different memory buffers. We are sharing this memory. So let's say you have a continuous recording that you've started with the JVM, and after a while you decide that you want to have a profile recording where you have turned on a little bit more events, and you have that running for a little while, and then that recording gets done, and you continue to have your continuous recording. If you were to make a dump, from when only the continuous recording was running, and into a bit of where you actually have the two recordings running, and you say, hey, dump the continuous recording between these two times. You're actually, for the time where you actually started profiling recording, you're actually going to get that data in your dump as well. You're going to get more than you asked for. You're going to get the union of the events. So that's how it works. So you will get at least, so the contract is, you will get at least what you asked for. You might get more if there are several users doing the recordings at the same time. So the different kind of events you can record for now are instant events, which that's just data points in time. Requestable events, and those are pulled from a separate thread. And you can, as a user, configure how often to get that data. There are duration events, and those have a start and stop time. So these are usually the most useful class of events, because you usually want to know how long something took, like a request. Did a request take longer than X seconds? So duration events are good. We like those. Timed events are like duration events, but they have a user configurable threshold. So as a user, you might not be interested in every single monitor enter event. You will get a lot in a heavily contended application. You might want to have just the ones where you had to wait for, say, 20 milliseconds. So then you can have a threshold and get less data. Okay. So there is, as I said, a lot of time has been spent on making this performant. So one way we get this performant is to use data that the runtime itself is already being collecting for one reason or another. The engine itself is built to be high performant. We're using timestamp counters on CPUs that support those, etc., etc. Another part of performance, you might consider testing to be part of performance, not just performance testing, but it performs well under stress. Oracle has really good stress testing. I mean, there's a lot of testing done before we ship the JVM, and having flight recorder on while we do that testing is a very good way to ensure that nothing bad will happen when you do this in a production system. Then there are third-party events. So there are already WebLogic server events available. DMS events, we have some experimental JavaFX events, and you can actually add your own, and this is not supported, but I have blogged about that, so I guess the cat is out of the bag anyway. Producing recordings. So there's one thing you need to do when you want to produce recordings. You need to start the JVM that you want to have a recording from with two flags. The very scary looking -XX unlock commercial features flag and the flight recorder flag. And we can leave all the questions about licensing to the end of the presentation. But it's free for development. You need to have recent enough JDK. So you need to have a 7U4. If you're just interested in recording your own events or getting WebLogic server events, you can use the 7U4. If you want to have the method profiling events, allocation events, all the other kinds of events that we record, you should use the 7U40 or later. It will be available in JDK 8 as well, with a slight regression in functionality, because the I/O events are not in JDK 8 yet. They will come back in 8U20, and please don't ask why. If you need to do remote monitoring, you just start up the external management agent like you normally would with this ComStan management flags. And in 7U40, there's a really neat little protocol you can use for broadcasting the presence of these monitorable and manageable JVMs called the Java Discovery Protocol. So, creating recordings. From within Mission Control, it's really easy. You find the JVM you want to do a recording on, you right-click on it and say, hey, I want to do a recording, and once you're done, it's going to be opened up for you in Mission Control. So this is probably one of the most intuitive ways of doing this. Sometimes you might have some other demands on your recordings that force you to use, say, startup flags. So this is very useful, for instance, when you want to record the startup behavior of your application, because there will always be a lag. I'm starting now. Oh, quick! Let's go to Mission Control and hook it up and get the recording done. And of course, that is a very good fit for using startup flags. And you can also use it to always get your recording at a certain time. So this example does a recording 1 minute after you've started the JVM. It starts up a 1 minute recording, I should say. So a 1 minute recording 20 seconds after you've started. There are means that you can customize and control what actually gets recorded. There are 2 different templates available from the start. So you have one called default, I think, and one called profile, and they're both in the JFR folder. One good difference, one improvement compared to JRockit is that the Mission Control client and the server-side part are now using the same template format. So you can actually, from within Mission Control, do recording, do all your fancy configuration stuff, export your template, and then put that template in the JRE-lib JFR folder, and it will, be available to anyone who connects to the JVM. So that's useful. And there is a remnant that is not so good from the JRockit days that is still with the HotSpot implementation, which is the default recording. It is useful though, so you can start with these options. The default recording equals true. That will cause the JVM startup a special recording with ID 0. And that is the only recording that you can use with the dump on exit flag. So there are flags that allow you to actually, whenever the JVM exits, it does a dump, which can also be quite useful. But then you need to remember to use the default recording equals true flag. And lastly, you can control the flight recorder from J-command. How many in here have not used J-command before? Oh, okay. Okay, so since 7U40, there is a very nice command line utility called J-command, which you can use. So I guess I'll do a quick demo of J-command. You can use J-command to control the flight recorder. So this is also quite useful. So let's start a few recordings just on, myself. So one way to start is to just go to Start Flight Recording. And I want to do continuous recording. Continuous is a hard word to spell. And here we go. So, and finish. So I should now have a continuous recording. The infinity sign there says that it's continuous recording. And I'm also going to start a time-bound recording as well with the profiling template for, say, 1 minute. Profiling. There are configuration options, so you can select what you want to. You should normally not need to go beyond this part of the wizard, because beware, there will be dragons beyond this point. You can configure everything, like every single event in detail. Let's have some fun here, like these guys. So you can configure thresholds, etc. for all the events, but normally you should not have to. Okay, so J-command is a very nice little tool where you can just, if you just type J-command, it's in the bin folder of the JDK, it will list all the running processes with the same effective user as you. So let's see. We have the Eclipse there, 1456, oops, and help to see what commands are available. And we see that there is a command called jfr.check, so we can see what recordings are actually running. So here we go, we have 2 recordings running, one named continuous, one named my recording, and you can do other things with this as well. So as you saw, there was a thread print command, so you can do thread print, and presto, you have a thread stack dump. It might be useful for scripts or whatever. So very useful little command line utility. I'm not going to spend more time on that because the flight recorder just got done the profiling recording. Very unexciting recording, so I'm not going to spend time on that one. But that's how you would do it. Okay. Normally I do a recording of something more fun, but hey. Okay. So analyzing flight recordings in Mission Control. This is a lot of text. I'll show you how to analyze flight recordings instead. That's easier. So, I'm going to open an example of a recording that I've already done. And in this recording, we can see that we are saturating the CPU. And might be a good thing, might be a bad thing. In this case, I think the application could probably go a little bit faster, so I want to know where I spend time in my code. So in this case, it seems like we are spending a lot of time executing stuff in linked lists. We have this index of, which is being called a lot from contains. Easiest is probably just to go to the call tree and get a nice breakdown of everything. And we can see here that we're spending a lot of time, most of the time, in count intersection initiator, which is something that we've written. And that calls into linked lists. So we probably want to open up that method and see what the heck is going on. And here's the example, really stupid demo program, where we have unique elements in a linked list, and then we have another linked list, and we do contains checks to see if, what elements are the intersection. And doing contains checks is proportional to the number of elements. So this is pretty slow, and we can do much better by changing this to a hash set, which I have already done. That should be the linked list here. We change from that to the solution, which would have been the hash set. Yeah, okay. So that's why it's slow. The problem, though, is that we wouldn't be able to actually see the improvement here. We aren't doing exact invocation counts or timings of these methods. So if you wanted to know how much faster the method now goes, you would need to do something else. So you could, for instance, generate your own events for this count intersection methods. Would be one way. So that would be one thing we could look at, the computationally bound problem. Then we have another set of problems, the sort of the flip side of the coin, which would be this. So here we aren't saturating the CPU at all, but I just wrote this wonderful, super multi-threaded application, which, is spreading the work on gazillions of threads, and I'm really unhappy about this result. But as you can see, we have a lot of Java monitor blocked events here. You can see here that we are blocking a lot, and there are various ways we could do to see why. We see the stack trace already here that we are waiting on logger log call. We could also go to the threads contentions tab here, contention tab, and see that, hey, seems to be a lot of contentions on instances of this class, but and we can also look at the lock instances to see it's actually the exact same instance that we are blocking on. It's just this one, and every single of these threads are blocking on this column. So what could we do? We could check out this method. and see if there's something we could do. And this is a silly example again. We could pretty much just get rid of the synchronization keyword here, because there is really nothing we are protecting in here. We could get each thread its own logger class, logger instance. We could, we could stop calling the logger. See, that is sometimes a really good thing. I know at least one big Japanese bank that stopped calling a logger in one particular place, and things went better from there. So that is always an option. So if we do that, if we somehow resolve this problem, we're going to see a very different view. So let's look at the recording after the fix. And let's put them side by side just to show how they changed. So from this to saturation. So that's good. And if we start looking at the events graphs, we will see that we don't block anymore at all. So much more in line with what we were trying to achieve. So, garbage collections, always fun. So we also record a lot of information about object allocations and garbage collections. So here, for instance, we can see that we are doing nothing but garbage collecting. I mean, if we zoom in, it's we garbage collect a lot. And the question is, of course, why we do this so much. And if we look at the pauses here, even the old collection we had here, we will see that there is nothing really standing out in the handling of the different phases. So it's probably just us allocating like nuts. And allocating like nuts makes us look at the allocations tab to see where we are actually doing all these allocations. And we can see that it seems to be Java integer allocations that are responsible for our allocation frenzy. And if we look at the allocator go method here, we can see that it does a lot of value of int, which is weird. So let's look at what this method does. And sorry about the not showing line numbers. That will be fixed in a later version. There is a way you can get around that, and if you want to know, you can come talk to me afterwards, because the information is there. Anyways, it's on this line. And you can see here that we're doing a lot of contains key on this map. And this little class here, somebody thought it would be an awesome idea to save a few bytes to have a primitive int here instead of an integer object. And we are going to autobox that all the time here when we do the contains check to integer objects, which will cause an integer allocation. And that's where every single allocation here is coming from. So if we just change this, having a primitive int coming in here is no problem, but if we change this to an integer object and this one as well, we're going to see a different allocation behavior in our application. So let's take a look at how that could look. Allocation fixed. Okay, so this is a lot lower resolution than I normally on, but so here we can see that our garbage collections now are exactly 2, and that's because I had a really stupid setting when I did the recording. It should really be 0. So compared to gazillions, we now have 2, and those are synthetically invoked. So it's heap inspection initiated GCs. So no more allocations. Whoops. So that's that problem solved. Now the really cool things start when we add higher level contextual information together with everything else we have. So we have information about the operating system, we have information from the JVM, we have information from the Java level of the stack, we have information from WebLogic to put all the other things into context. So what happens then is something like this. So we have a bunch of WebLogic specific tabs that show things like, SQL queries, servlet invocations, etc. And there is this notion of the operative set in Mission Control, which is a Boolean bag of events that you can bring with you between the different views. So let's say that we wanted to know what the first invocation of the view patient's servlet invocation looked like. We could add everything that is related to the same enterprise context ID here. So everything that has the same ECID as one of these view patients. And then we can see, it's very hard to see, but up there at the top, we just see that we have in Cyan, we have a little marker here showing that here is a bunch of events that are related to the invocation of that servlet. And we can go to the log, for instance, and we can take a look at, everything that was happening. But we only want to see what was happening in that particular transaction. So we select to only show the operative set. And then we can see that it started with the servlet request, continued with some enterprise Java Bean methods being called, some servlet, blah, blah, blah. I'm not a J2E guy. I don't know anything about this. We have transactions. We have a lot of other things happening. So we can keep continuing to use the operative set. So we can select everything that was happening in this transaction and say that we want to have everything happening concurrently. So add all the concurrent events. And concurrent in this case means happening in the same thread and during the same time as any of these other events. And voila, we can see that we have allocation events and method profiling samples and very low-level details showing up. And then we can just graph everything that was going on here. So first we see like everything. Let's see if we can find anything fun here. That really shows how crazy lots of information there is. So here we have lots and lots and lots of information happening, but we show only what's in that transaction now, the operative set. And here we go, a graphical view of what's going on in the first invocation of view patients, the view patients servlet. So it's really powerful. It takes a bit of getting used to this way of thinking, but it's really neat. Okay, so we'll see. I don't think I have time for. Yeah, maybe one more. So another thing you can see is exceptions. So you can record and see what exceptions were happening during the recording. So it's nothing really fancy, but one improvement compared to the old JRockit implementation is that you now get the exception message, which is very useful. So there was another team within Oracle that have very large configuration files, and they could see that there was an exception thrown from a badly configured one. But since we didn't capture the exception message, they didn't know on what line, so they were really unhappy. So this is a great improvement. You are now going to get the action message. And you can record your own custom events. And I think we are going to have a little bit of time for that maybe. So let me just run through these. There are some common pitfalls regarding some very commonly used events. So one is to not account for thresholds. So let's say you're looking at the blocking events and you see that the thread has been running for 2 minutes and that the sum of the latencies for the events for the thread you're looking at adds up to a minute. Does that mean that that thread was running unblocked for a minute? You can't know without thinking about your configuration of the threshold, because there could be a lot of these events just under the threshold. So you need to be a little bit careful. You need to always remember that this is an event recorder. It will record events, and it will record the kind of events and with the properties that you have told it to record. So that's not a limitation, but it's part of the design. Also, not accounting for CPU load. So if you haven't had any CPU load at all, if you don't have anything executing, relying on the method profiling data to guide your optimizations is probably not a good idea, because it's not representative of what's happening under load, and you will have very few sample points. If you have, on the other hand, the flip side of the coin, if you have full load, then spending time looking at the latencies is not going to improve performance much. You might want to look at where you're spending time executing Java code. And there is a bit of a tricky part here as well, because we are not using information, method profiling samples that are out in native blocking. So if you on your CPU graph see that you have a lot of machine load, you're the only process running, the JVM process is the only relevant process running, and you have bottomed out your CPU load for the machine, but you have almost no JVM process load. Well, then the method profiling information is probably not going to help you either, because you have sent everything out to, I don't know, OpenGL, you're playing with the lightweight Java gaming library, something, and we are basically measuring where you're spending the time, or where the JVM is spending the time executing your Java code. So that might be good to keep in mind. So, it's rather easy to build your own events and to add them to the producer. So you basically just subclass an event class. The text is really small here. I'm sorry about that. You can look at the slides afterwards, or you can just go to my blog, because I have a few examples there. But you use annotations to add the metadata about describing the events, and you create a new event, you tell when it should start, get the start timestamp, you push everything into the different fields, and you just call end to take the end timestamp and commit it to the flight recorder. So that's all you need to do. If you're worried about creating a lot of these small event objects, you can actually reuse them if you know that it's safe. And then you just call event reset.
Will you intend to retain the JRockit package name, or will you change your time?
Good question. So, So yes, we did retain it for these releases because WebLogic Server and others relied on them being there, which also makes it a little bit hard for us to just remove them. There will be a JFR, I'm not going to say 2.0 because Staffan hates that word number, but there will be a new version of these APIs in a better location. They will probably look quite similar, but not under COM or JRockit or, yeah. So yes, there will be a supported API later on, and it will be located in another package. And I just have 10 minutes left. Darn. So I'm gonna skip the customization demos, which is a pity. But if anybody's interested, we can just talk about it later. Okay, so there are some other efforts being researched. So one is to have a means of dynamically inserting flight recorder event generation. So inserting probes in running production code. I have a prototype running on my machine. I can show you how it could look. So basically, you would have either the option of having a template describing where you want these to be inserted, which you could give to an MBean, basically recompiling the classes, or you could do it with annotations so that you don't lose that kind of information when you start refactoring your code. It will still generate the events. Of course, then you would have a compile time dependency. Right, and one of the good things about Flight Recorder and Mission Control is that Oracle is continuously investing in this. So you can expect to see more events of different kinds. You can expect to see new and updated versions of the Mission Control user interface. We are currently working on some I'm not going to give you any details, but better I/O events. There will be more and more detailed GC events. We are working on, or we're done. From a development standpoint, there is nothing we can do to change 5.3 now, so it's going to go out very soon. 5.4 is going to go out with 8U20, and we are working with the next major version of Flight Recorder, which is going to support one of the features that I can talk about is automated analysis of flight recordings, because there is such a wealth of data and information that it might be, it's a little bit scary, first time you get confronted with all this. So we are trying to make it easier to guide you to what events are actually of interest for this current recording you're looking at, and highlight the different areas that might be of concern. And this is going to be extensible, so other producers of events within Oracle, such as WebLogic, is going to be able to produce their own heuristics for looking at the recordings. So they will bring their knowledge about analyzing flight recorders into this. I'm working with Oleg Masurov on the JavaFX team to provide events for JavaFX. So I have a prototype that I also be happy to show anybody who's interested, where you can see the different pulse phases and see which pulse phase took the longest. Makes it easy to see where you have performance problems when you do your JavaFX applications. There's also, there's a lot of different projects in the works that I think are promising. I didn't even know I had this still. I wrote a book together with a friend of mine, another Marcus, and people seem to like it. So, yeah, maybe you will too. And that was bad of me. Forget that one. Okay. So I think we have some time for questions, if there are any. Yeah.
So other app servers, are there any interest from other providers?
Okay.
Are they waiting for an official way?
So the question was if there is any other app servers that have shown interest in producing events for the flight recorder. And the thing is, it's an unsupported internal Oracle API right now. So I don't think there are. If there are any producers, or if anybody here is working on an app server and would be interested in looking at using these APIs, I'd be happy to help. So, I mean, there's nothing stopping you from playing around with these APIs. And along the way, hopefully, for JDK 9, there will be a supported API where you can actually start using it for producing your own events. Totally in a supported way that you know will still be there in a year or two. Okay.
What about license?
Yeah, I love that question. Okay, so the question was really, licenses, and the answer is kind of complicated because there is a license, commercial license for this. It's the OTN license. It's the standard Oracle license, which basically says, hey, you can go download this and play around with it as much as you want to. You can use it in development, etc. But if you want to use it on production servers, you need to go get a license. And I hate this because because it makes it so much harder to push this technology. But I heard quite recently, a few hours ago actually, that there is plans on a Java advanced license, Java advanced desktop license. And that sounded really promising to me because that means it, everybody could probably be able to get Mission Control in the future, and that should happen somewhere in February. But I don't know the actual exact details. I just know it will be much cheaper. So I have high hopes for that one. But free for development and free for evaluation purposes. And yes, commercial technology. Yes.
The method profiling, does it take samples at save point, or does it?
No. It doesn't use safe point sampling. It uses a version of async get call trace. So it's our own, and it's awesome. But no skew because of safe point sampling. So really neat. Yeah, sorry.
Writing to disk I/O is usually quite hard when you're mapping things. Do you do that asynchronously?
Okay, so the I/O, the question was that sampling in terms of getting information from writing to disk is usually very hard. So how do we go about that? And the answer is we don't sample that.
No, I mean storing the sampled data, because I/O and I/O is expensive.
Oh,
So
right. Okay. I misunderstood. Yeah.
Yep.
Yep. So the question was, how do we actually go about recording this data? Do we, writing to disk is expensive, and that is true. So there are various ways you can run the flight recorder, various different ways. One way you can run it is to have it just in memory. And there are many that prefer to run it that way because of the low overhead. So WebLogic Diagnostics Framework, for instance, set up a buffer, and all the events that are thread local will be recorded thread locally, without any contention. And then once those thread local buffers get full, they will be copied into in-memory buffers that are arranged cyclically. so we will continuously overwrite the oldest one. And you can dump the last X minutes of data that you have when you need it. That said, you can also configure it to write to disk. And yes, when it gets full, we will dump buffers to disk and back them up on disk. Yep. Okay. So the question was, unfortunately, how much is the license? And the answer is, that's above my pay grade. I have no idea. It's like, I'm just working here. Keeps food on the table for my kids. I have no idea. And I think if you talk to... So Oracle is kind of funny. If you just talk to sales person, you can usually get a much better deal than the list price. So what the actual price is, I don't know. But talk to sales, and especially talk to sales after this new and improved desktop whatever license. Unless you're running a multi-billion-dollar banking operation, then you should just talk to sales now. Okay, any other questions?
How much overhead do you expect for a normal tracking?
Right, so the question was how much the overhead would be expected to be. And it depends on the kind of application. We have seen less than 1%, in our performance testing. So for the continuous, I'd say it should be less than 1%. If you use the profiling template and turn on the allocation profiling, etc., bam, 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 you might see up to maybe 2% overhead. So it's really fast and it's really effective. In the JRockit implementation, which we have more experience of because these have been out for such a short time, but the JRockit implementation, I had a big Japanese company. Japanese are very thorough, trying this out before they put it in production. And on their particular application, they saw 0.5%, which they deemed acceptable. So, yep. Gentleman over there.
If the guys drifting my stuff is like, this is a security risk, whatever, what should I talk? What should I talk about?
Are they already doing heap dumps? Then this is nothing. No.
I'm not doing that either. Because
Okay. Yeah. Okay. So the question was, if the operations guys say that this is a security risk, what should I go tell them? And the answer is, this came from us wanting to get information from, and I can tell it now because they are dead and gone. Lehman Brothers had a really huge JRockit deployment, and we wanted them to run with what was called JRockit Runtime Analyzer at the time in production to give us feedback. And that was one of the reasons it was XML. It was easy for them to see what data they actually gave us and see that it is safe. But we are not recording heap information, as in instance information. So there won't be any bank numbers in there. There won't be any whatever your company is dealing with that is really sensitive. It will be information about how the application is running and what resources it is using. And there will be stack traces. And if you have other security problems in your application, such as if you are divulging things in exception messages that you shouldn't, we can't help you because you have done it wrong. But other than that, it should be okay. So take a look at the data that you get, for most purposes, I think it should be considered quite safe.
can I limit the connectivity from another computer to, it's just local?
Oh, you can decide. So the question was, can I connect to this from another computer, or is it just local? And the answer is, previously in the presentation, I told about different ways you could do recordings. And yes, there is a way that you can do it remotely, but you need to enable that through exposing running the JMX agent. If you aren't running that agent, you can't access this other than locally, and then you need to use some other means of dumping the data, such as using JCommand or one of the other techniques. So yeah, you decide. Okay, time. So thanks. It was awesome that so many showed up. Thank you.